Hello. So today we are going to talk about proportionality theorems. I've done a little bit of this with you in the past. This just kind of takes it to like a little bit extra. So triangle proportionality. If you have parallels happening here, then you have triangle proportionality, which means that this bigger triangle is proportional to the triangle inside of it. If you're doing a problem like this, you would actually start at what we would call the common point. So you would go the common point and go outwards in whatever direction. But that common point right there, that actually helps you a lot when you're actually trying to figure out proportionality and setting up a proportion. Now the converse of this is if the lines divide here and here, and you find out that they're parallel to each other, because these are proportional, these two triangles are proportional to each other, which means their sides are proportional, then this is parallel, therefore they are similar. Okay, you can do the same with three parallel lines. So let's say you have more than one parallel line. So you have these three parallels right here. And, excuse me, and you have proportionality between them. Sorry about that. So if these three lines right here, so UW right here, and YW right here, are going to be proportional to VX and XZ. And it makes sense because parallel lines will never intersect. Therefore, they're equidistant apart. Therefore, these have to be similar. So, and proportional. So, angle bisector, if you have a ray, and this ray is a bisector, it means it divided this into two equal parts right here and here, then the segments are proportional. So if you have a problem like this, you again find the common point, but this time you go out and up, and that's how you're going to set up your proportion. It's going to make a heck of a lot more sense when I actually do an example, which I will start now. So find the length of AB. So again, I'm going to look for that, what I call common point. I'm looking for this right here. This is the point that they have in common. And from here, I'm going to go straight out. And so when I set this up, I'm setting it up as x, because I don't know what that is. X over 6 is equal to 5 over 10. And you will find that x equals 3. Well, it makes sense. 5 over 10 is 1/2. 3 over 6 is 1/2. So that actually makes a lot of sense. Again, find your common point here and go straight out. Again, I'm looking for AB. I'm looking for AB. So this is 7 over x and 9 over 2. And so x equals 14 over 9. Okay, so if I'm doing the converse of that, I want to actually see if something's proportional. I'm just going to set up a proportion. So common point, 3 over 4 is equal to 4 over 5. Cross multiply, and you are going to see that this is equal to I said it differently before. This is equal to 16. This is equal to 15. So no, this is not parallel to this. That's what we're trying to show. If it's parallel, then these would be proportional, and it's not. So again, on this one, find your common point. And 7.5 over 5 equals 6 over 4. Cross multiply, and you get 30 and 30. So yes, these are parallel. So you can see how you can use this frontwards and backwards to find out what it is. You can also use this to solve for a variable. But first, let's figure out if we can complete the proportion here. So UV, UW, UV, UW is to XY as to YZ. So if you're comparing, you have this, and this, and this, and this. XY is to YZ as blank is to VW. So UV. And this one here, WU, WU, the whole thing, WV, part of it, is to ZY, part of it is to ZX. So the whole thing. So you can see how you can do that and set up proportions. Find the value of the variable. So I told you if it's a bisector like this, these are bisectors right here, then you're going to start with the point they have in common and work your way around. Start with the point they have in common and work your way around. So 9 over x is equal to 15 over 5. And so x is equal to 3. On this one, find your common point or the point of the bisector and work your way around and work your way around. Problem here is we got a little extra something happening. So we have 6.75, and we have our 9, and those are easy. But you have the whole thing is 14, and this is b. So you're going to set it up as 14 minus b, and then set this up as just b. So this is b, not 6. This is what my 6's look like. This is a b. So when you cross multiply this, do not forget that you have to distribute, because that's going to be the biggest error that you guys will make, is the fact that you will forget that piece right there. So you get 126 equals 15.75b. When you're done, you will end up with b equal to 8. So this right here is 8. Okay, a couple more examples. They're pretty quick ones. In this diagram, use the side lengths to find the length of RS. So this is what I'm looking for right here, the length of RS. I'm going to go from where my bisector is, or my common point between the two triangles. You see how they both have a P in common? That's where I'm getting that from. I'm going to go in and out, in and out. So when I set this up, I'm setting it up as 7 and 13, because I'm starting here and I'm going out. This one is going to be 15 minus x and x. So from here to here, 13 over x, and this is going to be 7 over 15 minus x to get this length. So that's where the 15 minus x comes from. It's right there. Okay, so you cross multiply again. Please don't forget to distribute, otherwise you're going to have a bad day. It's going to ruin everything. So you end up with x equals to 9.75. Okay, just don't forget that piece. Let's try these problems. Find the length of the segment. So I'm looking for this, and I set it up exactly how I see it. 16 over x equals 40 over 30. And x is going to equal 1.2. Set it up exactly how you see it. This time I'm looking for JM. 16 over 15 is equal to x over 18. In this case, x equals 19.2. All right, 2 more examples. And find the value of the variable. Kind of like what we were already doing. Start with your point. Go in and out, and 24 over 14, starting from here, 24 over 14 is equal to 48 over x. So therefore, x equals 28. If you need more help on how to solve proportions, please let me know because I'm just doing the math, multiply, divide. Okay, on this one, same thing. I know y'all are going to freak out about that square here, the square of 2, square root of 2. Well, here's the thing. It's just a number. So it's just 4 times square root 2. Don't get all wiggity wiggity whack about it. It's 4 over square root of 2 over 4, because you're going here, here, and then y over 4. So take a look at the problem. Before you even do anything else, take a look at it. What do you notice? Well, 4 over 4, so that means y must equal 4 root 2. So you don't even need to multiply it out. Okay, last one. In the diagram, angles 1, 2, and 3 are congruent, and GF is equal to 120, and DE is equal to 150, and CD is equal to 300 yards. Find the distance HF between Main Street and South Street. So HF, the whole thing here, is what I want to find. So 120 over 150, I'm getting that from here and here, these two right here, is equal to x over 300. So x is going to equal 240. But I'm not done yet, because this is 240. I want the entire distance. So 240 plus 120 is 360 yards. Okay, I hope you enjoyed your lesson, and if you have any questions, as always, please let me know.